let's see what you came up with. All right, so I'm going to go through them with you, and you can see if the answer that you were thinking is correct, okay? So let's look at A. So for A, I see that I have a pair that I can cancel out in the vertical direction. So my resultant force is 5 newtons. Resultant force is 5 newtons. Anybody got that? I think you guys may be overcomplicating it. It's not hard. Okay. Let's look at B. B, same. So resultant force is 0 newtons. Anybody get that? Good. All right, now C and D may be a little bit trickier to visualize. So let's see what's going on here. Now, they don't match exactly, but if we were to look at what we're doing here, we have 5 and 10 newtons. If I draw 1, 2, 3, 4, 5 strokes next to the 5 newtons and draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 strokes next to the 10 newtons, it becomes easy to see that I can cancel out 5 newtons out of the 10 newtons in the horizontal and the vertical direction. So I'm going to do the vertical first. So I cancel out 1, 2, 3, 4, 5 from here. Then I cancel out 1, 2, 3, 4, 5 from here. So what am I left with? 1, 2, 3, 4, 5 newtons in the vertical. Same thing here. Cancel out 1, 2, 3, 4, 5. That can match with 5 from this side. 1, 2, 3, 4, 5. And I'm left with 5 newtons. So my resultant force is going to be 5 newtons to the left or we can say horizontal. Let's just keep it simple. So we're left with 5 newtons in the horizontal. My pencil tool back. 5 newtons in the horizontal and 5 newtons in the vertical. Okay. So what about D? I'm going to give you a minute and see if you can tell me what my resultant for D is going to be. So you got to tell me. Okay, there it is. Is it vertical up or vertical down? Very good. Very good. 5 newtons down. Okay. Just in case anybody didn't get that, we canceled 5 and 5. Same from the horizontal, so nothing's left there. 5 from the top cancels with 5 from the bottom. and that leaves 5 left over, 5 down. Okay, so the resultant is 5 newtons down. Okay, good job. All right, so let me clear these annotations. Good. All right, so when we talk about balanced forces, it becomes very important when we want to use things like boats and planes. Okay, so in order to keep something, in this case a boat, in order to keep a boat moving at constant speed and depth, meaning it doesn't rise up or sink down, it stays right on the surface where we want it. In order to keep it at a constant speed and depth, the vertical and horizontal forces must be balanced. Okay? What are the 4 forces that are acting on the boat? So in the vertical direction, we have buoyancy and weight, or gravity. Okay? They balance out each other to keep the boat steady, not rising or sinking. Okay? And then we have air resistance and thrust. Okay? So thrust is the push forward that we get from the engine to make the boat move in the direction that we want. Okay? And then because the boat is surrounded by air, it also encounters some air resistance. And we call that drag. Okay? So when something is trying to move laterally, move in air, and it gets some resistance from the air, we call that drag. Okay? So air resistance, drag, same thing. Okay? A couple more people just joined. Let me just Ryan, Shamara. Well, oh, that's 2 Kimberlys. Okay. All right. So let's look at, what about a swimmer? So he also experiences the same 4 forces on him. Buoyancy, which we remember is the force exerted by an object that's trying to move through a liquid. Okay, so the swimmer exerts his force down on the water, and the water pushes back up on him. Okay, and then thrust moves him forward, and drag pulls him back. Okay, but he can move at a constant speed as long as all 4 of these forces are equal. Buoyancy is equal to weight, thrust equal to drag. Okay, what would happen if the drag got bigger? What would happen to his motion? We increase the amount of drag on the swimmer. Would he speed up or slow down?
I think he can slow down.
You're correct, absolutely correct. He's going to slow down. Okay, remember thrust moves you forward, drag pulls you back. Okay, good. Last example of this, where do we also see these 4 forces at work? Well, when we go on the airplane, okay? And we have another word for buoyancy, okay? So when we're talking about air, we call it lift, okay? So that's another word you might see. So lift keeps the airplane up in the sky and it balances out its weight. Thrust moves it forward, and then we have drag that acts on it simply because it is in contact with the air. Okay? Lift, thrust, weight, and drive are the forces that act on an airplane to keep it moving at a constant speed and depth in the air. Okay? So we have a swimmer, and I want to know what are the two forces, A and B, that are acting on him? What are the two forces, A and B?
Thrust and drive.
Which is which?
Thrust is forward and drive backwards.
Right. Very good. I see you, Alexia. Good job. A is thrust and B is drag. Okay? Good job. What about this one? Can you tell me how the forward motion of the swimmer is going to change if A is greater than B and if A is equal to B?
If A is greater than he wouldn't have the balancing need to move at a certain speed, and if is if A is equal to B, yeah, it would be balanced to move.
All right. Very good. Okay, so yes, Alexia. So you're correct, Shasta, that the force will be unbalanced, and that would mean that he would go faster. He would move, his speed would increase if A is greater than B. And if A is equal to B, the forces would be balanced and he would actually move at a constant speed. Remember, same force means still or steady speed. And of course, we know he's swimming, so he's moving. So he's going to be moving at a steady speed. Okay? Steady speed means he's not getting faster and faster. He's going at the same pace. Okay? Good job. So if A is greater than B, his forward motion will increase. And if A is equal to B, then his forward motion would stay the same. He would have a steady speed. All right? Look at my friend Billy. So Billy decided to take a drive and decided that I'm not going to wear my seatbelt. And of course, he had a huge accident. Why did he have an accident? Well, if you remember from the beginning of the lesson, we talked about inertia. And we said that inertia is the tendency of an object to resist changes in its state of motion. When you're riding in a car, the car is moving at a certain speed. And because you are in the car, you are moving at the same speed as the car. Now, the car has a system in place to change its speed very quickly. It's called hitting the brakes. If you hit the brakes and you don't have your seatbelt on, your body's inertia is going to cause you to keep moving at the same speed that the car was moving before you hit the brakes. And if there's nothing to hold you back, then you're going to end up like Billy over here with your head in the steering wheel. Not good. Okay? So if you ever thought about if anybody runs short distance races or you watched them before, when the runners reach the finish line, as much as they might want to, they can't stop right away. So because they've built up so much speed, by the time they get to the finish line, it's going to take them a couple more steps in order to slow down. So when you're going fast, you can't slow down right away, and that's because of inertia. You don't want to change your speed. So it's going to take another force that's greater than the force making you move to make you stop. And that's where your seatbelt comes in. If you are in the same situation as Billy on this side and you were going at a fast rate and you hit the brakes, when you do, you will lunge forward, but your seatbelt pulls you back so you don't go flying forward. It reacts to act against your inertia. Okay? So inertia wants you to keep moving in the same direction that you were moving. So you have to have another force to stop you from moving. Okay? Very important to wear your seatbelts. I guess you could think of it like that. It is resistance. Okay? So it's a force that's going to stop you from moving. That's what we want. Okay? Otherwise, Newton's first law says that an object that's in motion is going to continue to be in motion until something stops it. The seatbelt will stop you. Okay?